Welcome to the second topic in this course. We're now going to look in more detail at how the different electricity generation technologies work. The reason to do this is so that we can more completely consider what contribution different technologies can make to the overall operations of electricity systems. This will then set us up to consider the implications of variable renewables as they become more prominent in electricity systems. In most of the world, fossil fuels, coal, gas and oil, still dominate electricity systems. Fossil fuel power plants burn the fuel to produce heat, which is used to turn water to steam to drive turbines, thereby generating electricity. It can actually be more complicated than this, for example with combined cycle gas turbines that use both the compressed, combusted gas as well as steam to drive turbines. But what you need to know is that these plants can provide predictable electricity generation. Their output can in general be increased or decreased in response to demand changes and in response to plants going on and offline. So they can provide varying degrees of flexibility depending on the plant design. At this stage it's worth pointing out that all electricity generators are subject to uncertainty, for example unplanned outages, and that system planning includes flexible backup and ancillary services to address such uncertainties. Other thermal plants, such as biomass plants, often with the biomass being co-combusted with coal, also generate electricity in the same way as fossil fuel plants. We are still on a steep learning curve around how to design these plants to be flexible so as to better meet the needs of a more dynamic electricity system as variable renewables come into play. And this is also true of fossil fuel and biomass plants which are fitted with carbon capture equipment, which absorbs the majority of exhaust carbon dioxide from such power plants to make them much less carbon intensive, but which still hasn't been commercially developed beyond one or two full-scale examples. We also have nuclear plants in which the process of fission, essentially the splitting of the nuclei of heavy elements like uranium, plutonium and thorium, generates heat and then steam to drive turbines, as with other thermal plants. Nuclear plants are relatively inflexible compared to other thermal power plants, though in some countries such as France, where nuclear provides almost 80% of electricity generation, there is a relatively high degree of variability of output, which can be achieved through a variety of means, depending on the precise plant type. Hydropower plants come in a variety of forms. Dammed hydro plants rely on using water stored at a height in reservoirs and lakes to drive turbines as the water falls to lower levels. Pumped storage hydro uses water that is pumped up to a height during times of relatively high electricity supply availability compared to demand, and then released for electricity generation when required. Both dammed and pumped hydro can be used relatively flexibly and predictably. In Brazil, for example, hydropower makes up 75% of all electricity generation and most of the baseload. Run-of-river hydro, by contrast, generates electricity from the flow of water in rivers and streams, often with little or no storage, which makes it less predictable in its output. Then we have other renewables which are weather and geology based. These include geothermal, tidal and wave, as well as wind, solar photovoltaics and concentrating solar power. Geothermal uses heat from the Earth's interior to heat water into steam, again to drive turbines to generate electricity. It's not a variable source since the heat source is constant. On the other hand, tidal, wave and wind are variable, as their output depends directly on the predictable tide and the less predictable waves and wind. These mechanical technologies all use the motion of the water or wind to drive turbines which generate electricity. Solar photovoltaic panels are made from specific semiconductor materials which capture energy from the incoming photons that make up sunlight, converting it into electricity. As such, Their output depends on the levels of sunshine, known as solar insolation. Concentrating solar power uses vast arrays of curved mirrors to concentrate sunlight into small areas, heating water to steam and driving turbines. These technologies can be combined with heat stores, allowing them to generate electricity on demand. So that's a summary of how the different electricity generation technologies that we're likely to see in the coming decades actually work, and gives an idea of their predictability, variability and flexibility. You can find more information about these technologies, specifically on how they work, their operating characteristics and their typical costs, in the additional material that accompanies this video. We're now ready to consider in further detail what specific impacts and contributions variable renewables can make to the overall operations of electricity systems.